Hello everyone, greetings from S Technologies. Today I would like to give an overview on SAP Asset Performance Management, in short SAP APM. First of all, SAP APM is a part of our Intelligent Asset Management portfolio. It includes all the solutions that SAP has to offer in the area of asset management. SAP APM is a cloud solution that is meant for industries such as oil and gas, power plants, steel industries, etc. Who wants to run the asset maintenance as outcome-based operations with a focus on high asset availability, resilient and safe operations. APM has two components, that is asset strategy and asset health, which is seamlessly integrated with enterprise asset management. Here we can optimize the asset strategies using scientific methods such as risk and criticality, RCM, etc., which monitors the asset health using predictive maintenance. Overall, the main aim or objective of the SAP APM is to increase asset performance, reduce maintenance costs, and deliver service excellence. Now let me showcase the live demo scenario. In S4HANA system, equipment has been created along with its relevant or required data like location data, organization data, manufacturer data, class and characteristics, measuring points, catalog profiles, etc. And a sub-equipment also assigned to it to form a hierarchy structure under the functional location as shown below. Now, let me log into APM system to showcase the same hierarchy in the APM. After providing the login credentials, it opens APM landing page as shown here. So, under that explore technical objects, we need to select the equipment to see the hierarchy which is created in S4HANA system. Here our equipment is 636. So these are the details which we have maintained in the S4HANA system. To see the hierarchy, this is the button which is contextual hierarchy. We need to click on this. So the hierarchy is being displayed. Class and characteristics created for the equipment in S4HANA are replicated to APM and are viewed here under the class or characteristics tab. So these are the class or characteristics we have created in the S4HANA system. Measuring points created for the equipment in S4HANA are replicated in APM and are visible as system indicators under the indicators tab. This one. So these are the indicators here. This is a combination of indicators here, system indicators and the local indicators are here available here. In order to capture field sensor data, we can create the local indicators in APM with UOM which referenced by S4HANA characteristics. To create the local indicators, we need to select this create button. Once equipment successfully synced with IoT, we can able to capture the sensor or indicator data. So measuring documents created in S4HANA are updated as system indicators data, whereas field sensor data of asset will be captured as local indicators data. So here for the temperature, we have pushed the value as a measuring documents in S4HANA system. The same thing we can see it in the indicator chart also. When the sensor data being collected for an equipment, this can be monitored on the indicator chart and indicator table, which enables to take real-time decisions based on the deviations. So we need to select the indicator and the date. So here you can see here the value. As a part of condition-based monitoring, using rule engine, we can generate alerts and notifications when the sensor data reaches the thresholds. System automatically generates alerts and PM notifications. The PM notification will be auto-synced to S4HANA backend system. These will be displayed on the monitor alerts tab. There is a tile on the home page, monitor alerts tab. So here you can see the notification number. An alert has been triggered, and for that alert notification has been generated. So it's the same thing. This is the vertical arrow here. This can be here. This is the indicator chart here. Before starting to define maintenance strategies in APM system, there is a prerequisite that we need to maintain, which is catalog profile along with the failure modes for the technical objects in S4HANA system. So here there is a failure data profile, this catalog profile. This one we need to maintain in S4HANA system so that the failure modes and everything belongs to this will be replicated to APM. Risk and criticality assessment. In short, we'll call it as R&C assessment. It is a process to identify potential risks and hazards and their consequences on the asset and calculate risk score based on different categories. R&C assessment will be performed on the asset based on the failure modes that were impacted on different categories such as safety, production, environment, etc. Each impact will be measured with the scale which generates the final risk and criticality score. Based on risk score, will be performing corrective maintenance activities like RCM or FMEA. Now here, reliability engineer will be starting to perform risk and criticality assessments. Let me navigate to the APM and risk and criticality one. There is a separate tile called risk and criticality assessments in the home page. In order to perform R&C assessment, we need to define impacts. It means if the asset or technical object got failed, where it is getting impacted. For each impact, it's a prerequisite to assign two dimensions or quotients along with its respective scales or answers. So here we have considered the impact as safety and production. In our case, our technical object is blower motor, and when it is failed, it got impacted on safety and production areas. For safety impact, we have defined the dimensions and scalar answers as follows. So here for the first dimension, what is the impact on safety? For that, we have considered the scale value as 7, which is requires medical attention. Here there will be scale values here 1, 3, 5, 7, 10. The scale values will be in a numerical format. And the second dimension is what is the consequence on safety. And further the scale value is 10, which is catastrophic. Here also same scale values will be in the numerical format. Similarly for production also we have considered two dimensions, and we have done the same process as we have done for the safety. We have considered the dimension as how much is the production loss and the downtime is generated. For that respectively we have assigned the scale values. So here the scale risk score will be first, it will be calculated individually for safety and for production. Then later on the overall score will be considered here. As you can see here, for safety we got 17 and for production 35. Overall risk score is 52 here. So now, like after performing the R&C assessment on the technical object, as a risk score got generated, now APM system provides an option to change the resultant criticality at the backend system accordingly, and which is an optional one. Based on the RCM assessment, now reliability engineer suggests an action here. So here he suggested an action to be performed is RCM here. Let me move to the RCM as per the action item. RCM stands for Reliability Centered Maintenance. Here also reliability engineer will start to perform the RCM assessment. RCM is a widely used methodology that determines the most appropriate maintenance strategy for high critical assets. It enables maintenance professionals to devise a tailored maintenance plan that ensures an asset performs optimally in its current operating context. This concept of maintenance planning is crucial to ensure that an asset continues to meet the user's requirements. RCM assessment for technical objects, which is based on the SAE JA 10112 standard. There are 7 standard steps for the RCM processor. We call them as 7 standard steps or standard questionnaires. What are the functions and associated desired standards of asset performance in its present operating context? Second one is, in what ways can it fail to fulfill its functions? Third, what causes each functional failure? Fourth, what happens when each failure occurs? Fifth, in what way does each failure matter? Sixth, what should be done to predict or prevent each failure? And the last one, what should be done if a suitable proactive task cannot be found? To perform RCM assessment, we need to define appropriate functions, functional failures, and failure modes related to the technical object. So there is a separate tile called RCM in the RCM assessment in the home page. Here in the assessment, we will be giving the functions, functional failures, and failure modes related to the technical object. Here for the technical object, which is blower motor, function is also a blower motor, functional failure is airflow, and the failure mode is pairing failure. For this failure mode, we need to assign causes and effects. So here we have assigned causes and effects. As per the standard RCM process, consequence evaluation will be carried out one by one to the technical object. As a result, type of consequence and consequence score will be evaluated. In our case, type of consequence is safety, risk, and consequence score is S5. So here the type of consequence is safety, risk, and consequence score is S5. We considered these questions here. We can see questions also. What are the questions we considered for our consequence evaluation? So these are the questions. Reliability engineer will provide necessary or required recommendations based on this consequence score. For example, if the action item in risk and criticality assessment is FMEA instead of RCM, then we need to perform the FMEA assessment. So the process is also same here. We'll be giving the impacts here. 2 impacts will be given, and the risk score also will be generated same as we did for the risk RCM previously. So the risk here it is FMEA. Let me move on to FMEA. FMEA stands for Failure Mode Effects and Analysis. It identifies and suggests actions to either eliminate or reduce potential failures from occurring. RPN is a numerical assessment of the risk priority level of a failure mode or failure cause in an FMEA analysis. It helps the responsible team or individual prioritize risks and decide on the corrective actions. FMEA RPM is calculated by multiplying severity, occurrence or probability and detection indexes. Severity, occurrence and detection indexes are derived from the failure mode and effect analysis. To perform FMEA assessment, we need to define appropriate functions, functional values, failure modes related to the technical object. Now let me move to the APM system to show you the FMEA assessment. Same here also reliability engineer will be working. In our case, for our technical object is blower motor here. Further, the function is also blower motor and the functional failure is also BL motor here. Failure mode is bearing failure. For that failure mode, we will be assigning causes and effects. At causes, we will be defining the occurrence score and the detection score. We will be defining the severity also. Here also the severity will be in the numerical format. Scales will be given. Here 6 is there, which is moderate. With respect to severity, occurrence and detectability, RPN score will be generated. RPN is nothing but risk priority number. Here the RPN score is 288. Based on the RPN score, reliability engineer will suggest the recommendations to either perform preventive or corrective tasks. Recommendations and implementations workbench. Recommendations means a course of action that will improve the asset condition by defining the optimized strategies. Implementation workbench means here maintenance engineer leverages the recommendations and their specifics to transfer them onto the relevant planning group for execution. Let me showcase you in the APM how we are doing the recommendations. So recommendations can be done in two ways. Either we can do it from the RCM or FMEA. There is like a separate recommendations is there, or we do have a separate tile here for the recommendations workbench here in the home page. Normally, in the business scenario, we'll be doing it from the from here itself, either from RCM or FMEA. So based on this FMEA, based on the RPN number, here reliability engineer suggested to do the preventive maintenance task in the recommendation. So here we will be giving the general data as preventive maintenance, maintenance activity type, priority and discipline, impact on business and the type, and the other data which comes from the technical objects. Here this is the failure data we have got here. It will be showcased in a graph mode. So this is how, like these are the causes, failure mechanisms and failure effects we have considered in for that risk and criticality, and these are the technical objects. This recommendation is in released state. So for the created recommendations, we can change the status to review, reject or hold. So it's already in review status. So here there are two options available: on hold, reject, ready for release, or we can put it again into the in process. For the released recommendations, so once the recommendation has been released, maintenance engineer can do required implementations at implementation workbench. So for this recommendation, actually it is already implemented here. Maintenance engineer. So in the recommendations, maintenance engineer will be working. Let me show you how the implementations recommendation will be there. So this is a style. From the recommendations only, like once the recommendation is released, then only we can see it in the implementation workbench. There is no option to create a new implementation workbench recommendation here. So this is one. Here maintenance engineer can analyze and review the promoter recommendations to take the right actions. Once it is done, then he can put the status to implement. Otherwise, if there is any rework required, he can send it back to the reliability engineer to work on it again. So he can click on this rework required. When he click on this, it goes back to the reliability engineer. This is all about recommendations and implementation workbench. Failure curve analytics. The SAP APM failure curve analytics curve is a graphical representation that illustrates the relationship between asset failures and time. By analyzing the failure analytics curve, organizations can identify trends, predict potential failures, and proactively address maintenance needs to prevent costly downtime and disruptions. So at the home page, there is a tile called failure curve analytics tile. Here will be we need to create the model first. After creating the model, we need to assign the technical objects for which failure curve analytics wants to perform, and PM notification data should be available, minimum of 10 for respective technical objects. Once the data is available, then we need to select the notification start date ranges and select this train and score button to train the model for respective technical objects to predict the failures. Upon successful completion of the failure analytics, we can able to see the failure prediction day along with the graphs. So here we'll be getting to know the status is completed or not. Once it is completed, we need to go to this explore technical objects tile, and there is a tab here which is analytics. Here we can see the details like failure prediction day. So this is the model configuration, and this is the failure mode. Here we can choose failure modes, for which failure mode we have trained the like that one in the FCA. So we have considered here bearing failure. Here maximum of 40 per technical object we can give, and it is showing the predicted failure date as April 15th. Time to failure is 7 days. So this is the graph. Here the age of the equipment will be shown, and the conditional probability of failure is 100%. So this is all about failure curve analytics. Thank you for your attention, and now it's open discussion for any clarifications.